Alright class, now we're going to talk about the other way to find slope that's not using graphing, and we're going to do it algebraically using the slope formula. The slope formula is a great tool in order to find slope without having to graph. And there's a couple ways to do it. One's actually using this slope formula, and the other way is another little short method that I use. But in order to use the slope formula, you've got to label things. Now notice this is an x, this is a y, this is another x, this is another y. Well, we've got two of them, and just like the formula says, there's a 1 and there's a 2. This is y sub 2 and y sub 1. And that's just, there's nothing special about it, it's just labeling them numerically and giving them an order. So what that means is I should call this one, this first one, the 5, the x1, because it's the first one, and then y1 because it's the first y. So in other words, this is the first coordinate, and then this will be the second coordinate, so that this will be x2, y2. It's just labeling it as the first point and the second point. So when I plug it in the formula, I would put the 1 where it says y2, so I say 1 minus the y1, which is the 2, divided by x2, which is the 4, minus x1, which is the 5. And then all I have to do is simplify. So 1 minus 2 is negative 1, divided by 4 minus 5 is negative 1. And the answer is negative 1 divided by negative 1, which of course is positive 1. The slope is 1 for this first one. And doing the same process for the second problem, I would label again this x1, y1, x2, y2. So now I take and do 6 minus 3 divided by 4 minus negative 2. And then it's just a matter of simplifying. There is two negatives, so I got to change the signs. So I get 6 minus 3 is 3 divided by 6, and that reduces to 1/2. So the second slope is 1/2 using the slope formula, and that's not having to graph them. Now I said there's another method, and I'll show you that. And that method is just kind of a shortcut without having to memorize this formula. But the nice thing is you're at home, you can generally use the formula. But if you don't want to use the formula, this is the stack method. So to stack it, what you do is you take the second coordinate and stack it underneath the first one. Or sorry, the first one stack it underneath the second, or vice versa, it doesn't matter. Stack either way. And I get 4, 1 over 5, comma 2. And what you do is you go ahead and stack. So the first step is stack, then you subtract. So I subtract by subtracting the 5 and the 2. So I subtract both of them. So 4 minus 5 is negative 1. 1 minus 2 is negative 1. So now I've got to do my last step with these, which is stacking in. Now we stack the left one underneath the right one, like that. So that gives you the same answer we had before, which is positive 1. So it's stack, subtract, stack again. It's just another little method without having to memorize the formula. So if I do it on the second one, we always stack the left one over to the right one. Left over to the right, so I would stack this negative 2, 3, and now I subtract them, so I change the signs. And 4 plus 2 is 6. 6 minus 3 is 3. And then I stack them again. And then just simply reduce, and I get 1/2. The same answer I had before. So that's just the second method. Now we've got to talk about slope, two special types of slope. And the slope of a line like this is what we're talking about. Now, in order to understand this, what we need to realize is what slope is. Slope is, and where we see slope in real life, slope has to do with roofing, or just general water runoff. Okay? Now, if you're looking at this line right here, if that was your roof, the question you should ask yourself is the water sloping off? And the answer is no, it's not sloping off. So what is the slope? Well, it's zero slope, or no slope, because it's not sloping off. If I had it raining right now, rain coming down on this roof, Okay, you could imagine all the water pooling up and then finally breaking through your roof. So the answer for that is no slope. So when the problem says, what's the slope? The answer is none. And how you get a line like this is you get an equation that says y equals something like, this one would be 1. Y equals 1 would give you something like this where you have no slope. Whenever it's a y equals, you get no slope. Now on this one, this is the slope of this red line here, we have a different type of slope. It's not no slope, because again, you're supposed to think about this in terms of water. Because again, slope has everything to do with sloping off water. Well, if it's raining, so let me show some rain like this, okay? Well, what happened? The rain never touched the line. So that's different. It doesn't have anything to do with the rain. It's not sloping the water off at all. So we can't say no slope. It's not even, we can't say anything about the slope actually. There's nothing we can say about the slope because the water's not even touching the line. So in this case we have to say it's undefined, because there is nothing we can say about the slope because it doesn't slope anything off. It's not no slope. It doesn't, we can't even say anything about slope. So we have to say undefined, and then we see this in equations that are x equals. So in this particular one it'd be x equals 1. If I was to draw another line, this green one here, it's just wherever it touches. So it touches right here at -1, 2. So at -2, that would be x equals -2. So whatever the number is, that's where you get a vertical line with undefined slope.